Hello everybody and welcome back to another OpenGL stream. We've just been blasting through this content here. Ooh, new Java version. Today we're going to be continuing our conversation with lighting. And today we're going to look at how to create different types of lights. We'll be looking at stuff like directional light, which is something like the sun. And then we'll also be looking at spotlights, which is like a flashlight, and then point lights, which is kind of what we have with our lamp so far. And then after that, we'll also be looking at how to combine different lights to create a whole sort of environment with a bunch of lights inside of it. Okay, so right now, what we have in our environment is this thing right here. So right now, that's looking pretty good. I think this is emerald or something. But our problem with this is that, before we get into the different types of lights, we do have to address one of the problems here, and that is that the entire shader or the entire object is set as one material, and this is not usually going to be the case, especially with if you have boxes or something, or just any object really is not going to be a uniform material. So to combat this, what people have created is, within textures themselves, we have found a way to create a secondary texture that tells us how much specular light should be reflected. So first thing we're going to want to do is that we're going to find a new image to do, and I'm going to be switching it up on you, but today we're doing the Soviet flag, so I'm just going to go ahead, and this link is in the video description. I'm going to save this image as a PNG for now. Flag.png, and I'm going to go save it in my assets folder where the other images are. Yes, save it there. So this is our Soviet flag, and let's make believe that this is, the Soviet flag is, let's make believe that the red part is wooden, or like a dull metal, and the yellow part is a shiny metal, it's like gold. So we do have gold properties, actually, in our materials classes, but that would be kind of hard to program into this image. So the way we're going to do it is we're going to keep the flag here, but then we're going to make something called a specular map. But for right now, let's just go ahead and add the image in and see how it works. So where do I want to put this image in? So go into cube.h or cube.hpp, and down below in initialize, let's go ahead and create a texture. So we're going to say texture text is equal to, or we'll just initialize it with, how do we include, we need to include the class as well. So in this constructor here, I forget what we put in, path and then name. Okay, so our path is going to be assets/flag.png, and then we'll just name this the flag. And then what we have to do next is just get the assets and just refresh it so we can include the image. All right, and then after that, let's say text.init or .load. And then in the mesh, when we initialize our mesh, we want to add that in the vector. So in curly braces, add the texture there. Okay, so rather than doing a material.ambient, so right now we have our material up here, and this determines the color of the object. So rather than having that as the ambient here, what we're going to do is we're going to change our fragment shader. So go into object.fs, and what we're going to do is we're going to get rid of our ambient, because in many ways ambient is pretty much the same as diffuse. So we're just going to have it as the same thing pretty much. So just delete that, and rather than passing in a vector for diffuse, we're going to pass in a texture coordinate. So sampler 2D. So diffuse becomes sampler 2D because we're passing in a texture. So once we have that, we have to go ahead and change that in cube.hpp. So we don't set the ambient value, and instead of saying shader.set3float in cube.render, we're going to say shader.setInt, and we're going to keep it as material.diffuse, but instead of passing in material.diffuse, we're going to say mesh. Let me just make sure I'm getting this right. We are going to say mesh.textures at 0, because this is the 0th texture, and we're just going to pass an ID. So it's almost like saying texture.activate, but instead of, you know, we can actually, let's go ahead and do texture.activate. So instead of naming this flag, let's name this material.diffuse. So material.diffuse. And then we can say mesh.textures at 0.activate. So this will activate the texture at material.diffuse. So next we just need to change a couple of calculations in our fragment shader. So let me just go here. I just need to make sure I'm doing this right. Okay, so the ambient is gonna stay as the ambient is going to be the light strength, the ambient light strength, and then instead of multiplying it by the material.ambient, we're going to get the texture color at the coordinate. So we're going to say light.ambient times a 3D vector of the texture, and we're going to pass in material.diffuse because that's the texture, and we're going to pass in text chord because that's the target coordinate that we want. And remember, text chord comes from that vertex array, so that's all going to work out. And then we're also going to want to do the same thing for diffuse, and instead of, you can actually just copy that because diffuse and ambient are practically the same thing. It's just the only thing that will differ them is the light strength. So light.ambient is gonna distinguish ambient light from diffuse light. Okay, so let's go ahead and run this, and I hope we don't run into any problems. Let's go ahead and try and run this. Okay, that works, good. So we're getting pretty much the same thing. I mean, this is a square flag I can't run. You know, actually, let's make this scaled properly. Well, no, there's not going to be a way to do that. There's not going to be a way to do that, so we're just going to leave it as a square. But you see that we still have not solved the problem, because it still treats everything as the same thing specular-wise, but you see now how the texture is affecting the ambient and the diffuse light. That is very low res. Still a beautiful flag. Ooh, okay. So let's go ahead and see how we're going to solve that problem. You can actually delete this comment up here. Before we proceed, I do just want to get rid of all the mixed value stuff. So where we set like the mixed value, because we won't be needing that. So you can delete that in the process input in the main file. Okay. So, like I said, we're going to try and treat this flag. So let me just make a copy of this, and I'm going to open it up in paint.net. You can open it up in any editor really. But let's treat this as if the red was a wood and the yellow was some sort of shiny metal. So how would we be able to tell the fragment shader to shine specular light off of the metal and not the wood without giving it a material for each coordinate? Well, we can actually do that based on the colors of the image. Now you can customize this a lot, but just keep it simplistically. the kind of process to do this is to make this a black and white, transform it to grayscale, and then from that increase the brightness and contrast a little bit. So let's see how this will work. So in paint.net, I'm going to go to adjustments and then just make it black and white, and you see that. Now what you will notice is that the yellow part is a lot brighter than the red part, and that's what we wanted, because we want the whiter part, which will have a higher RGB value, a higher normalized RGB value, which will result in higher specular light. So we want that higher. So now we can just increase the brightness a bit as well, or the contrast first, because we don't want the wood. If this was red wood, it wouldn't have any specular light, just because just because wood doesn't reflect light well at all, actually. So if we just increase the contrast, you see that the black is the red area is getting darker while this is getting brighter, and then we can also just increase the brightness a little bit, but you don't need to do that. Ooh, look at that. Now if we really wanted to do that, then we could, but we'll just leave it like that for now. You can play around with this and see what happens. So I'm gonna hit OK. I'm gonna save this. Click OK there. And then I'm gonna rename this as flag underscore specular. And we're gonna load this in like any other texture. I mean, we'll look at how to transform Obama in another video, but right now we'll just keep it at this flag. So let's go back in cube.hpp and let's load in this texture. So we're gonna say texture, text specular, and we're gonna load it in as assets/flag specular.png, and then we're gonna name this material.specular. So material.specular, just like we did for diffuse, and then we're gonna say text specular.load. And then likewise down here in the render, we're gonna replace this shader.set the specular float with simply mesh.textures at 0 or textures at 1 dot activate. And then we can just replace the shininess with a 0.5, 0.5f. So you see that we've actually just nullified what we did with the material. That's gonna be, it's honestly completely useless. I was just doing that for demonstrations, but you don't need to have that whole class there if you don't want it. So let's now go back into our object.fragment shader, and let's change up the code a bit. So specular is now going to go from a 3D vector to a sampler 2D, because it's a texture. Now we need to change a couple of things here. Just make sure I'm getting the right ones. So when we go ahead and calculate the 3D vector for specular, we're going to say light.specular times spec times, but not material.specular. We're going to take a 3D vector of the texture of material.specular and apply the text coordinate. So that should be all that there. So we're essentially doing the same thing that we did with diffuse, but rather we're taking the specular property of it. So let's go ahead and run this and see what happens. Oh, we got an error. Mixed val. Yes. Yeah. Just delete all instance. If you don't want to, don't have to. But I'm just going to delete that because we only have one texture, so it's just wasted processing power. Oh, okay. Vector subscript. Oh, yeah, that's right. Which you also need to include it when we load in when we load the texture into the mesh. So do text and then text specular there. Okay. Now it should run. Okay. So this looks okay for now, and what you can see is that the specular value for the red is a lot lower than what it was, and if we look at the yellow, oops, you see that it's automatically brightens a lot. Like, and if I do that, like, you see that it even within, because you see that there's a part of it that just automatically doesn't that in between the red and the yellow, it just gets a lot brighter. So this will seem as interpreting the yellow or the gold as much shinier than the red. And I don't know why this is. I think I need to change the filters on my images. Let me play around with that real quick. because that is kind of bothering me. What is that? Set filters, GL linear. Let's just do both GL as GL linear. I'm just gonna test this out. Nope. GL nearest. Let's try that. Nope. I don't know why it's... Yeah, this is weird. Yeah, nothing's working. That's weird. I need to figure that out. Don't change anything. Okay. So yeah, that's kind of the whole premise of that whole thing right there. Okay, so like I said, we got rid of the material usefulness, so you can actually just go ahead and remove that from the parameters. I know I did spend a little bit working on that, but it's not too necessary. And then just make sure to remove that when we initialize the cube as well. Okay. Alright, so that is how that works. Now let's open up something else. So that's called lighting maps, that whole thing that we did with the specular mapping. Now let's look at lighting casters, which is something a little different. So like I hinted at this before, but what the light we have now just casts light in all directions, and that's pretty cool, but one, that's not realistic, because a lamp does not, the intensity of a lamp does not just stay the same. Like it decreases in intensity as you go further out. I'm just gonna find the page I want. So we're gonna look at different casters. The first one's gonna be directional light, which is, like I said, like a sun. Then we'll look at point lights, which is like the lamp, and then we'll look at spotlights over here. Alright, so let's first look at a directional, or before we do anything, let's go ahead and create an array of 10 cubes, just so we can see some of these effects here, so we don't only have one cube. This is going to be annoying to type in, so, you know, whatever, we'll do. Okay, so delete the cube that we have now, and create an array of cube positions. So we're going to create a vector 3 array, and we're going to have cube positions. And, oh, what's going on? What is that? Oh, okay. So, and then let's just paste in, or put in a couple. So GLM vector 3, let's put one at the origin, 0.0 and 0.0, and then let's just copy this 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you should have 10 in total. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. Let's make a second one at, let's go 5.0, 6.0, and negative 2.0. Let's do 1.5. You know what? I'm not gonna type all these in. I do have this. Where's this? This is on this page somewhere. I need to find it. If you just don't worry about these positions, or just this will be on my GitHub by the end of the video, so you can just copy those positions from there. I don't know if I mean, there are like 3 million people watching this, so I might want it, but you know, it's fine. Alright, so those are our cube positions. So now let's create an array of cubes. So cubes, and we'll size it at 10, and we'll say for unsigned int I is equal to 0, I is less than 10, I plus plus. We're going to say cubes at I is equal to a cube. We're going to call the constructor, and we'll pass in cube positions the ith position in the array, and we'll pass in just glm_vec3, and we'll say 1.0f. And then we'll initialize it. So cubes at i.init. Alright, so that initializes all 10 cubes. Now let's just go ahead and display these and see how it looks. What did I do? Banger's coming up. Hold on. Oh yeah. Alright, now let's go ahead and render each cube separately. So we're going to say for unsigned int I is equal to 0, I is less than 10, I++, and we're going to say cubes at I.render shader. Alright, and let's go ahead and run this and see how it works. Oh, yeah, I know why. Because we did the cleanup. So just do the exact same loop, but instead of render, just call cleanup. Okay, and you don't need to pass in a shader. Oh, yeah, and then get rid of the material property in the cube. I forgot to delete that. Oh, and then in the lamp, get rid of the material parameter there. So just remove all instances of material. I did neglect to do that. Okay, now we have 10. Oh my god, that's a lot of fucking flags. But you see that that's going to be specular. There's a little bit of specular right there. We should see some specular over here, and we do. And there's more specular on the logo there. Now the one issue that we do see with this is the intensity, like I talked about. Like, this should not have the same light values as the cube up there because that lamp is so far away. So eventually we will look at how to create like a model to describe how the light strength decreases as you go farther away. Okay, so the first mode of light, let's get into it. It is a directional light. So it's something like the sun, where it's so far away, well, it's considered infinitely far away. And as a result, all of its light rays will have the same direction. They're all going to be parallel. And it doesn't matter where the light source is, well, because it's always just beaming down on us. And that, well, they're independent of the location of the light source at a single time. So, like if we were to simulate a sun at noon, we would make the light -1 in the y, and that's it. And then if we were simulating a sunset, well, that's west, so that would be the sun's in the negative x side, so the direction would be just +1 on the x, and that's it. But that would vary as we go, but we could simulate that later. Anyway, we're gonna look at how to do this. So let's look at our object.fragment shader and find our light. Now the first thing we're going to want to do is comment out the position, because like I said, it's independent of position, or we will be calculating the position not in, or we won't be setting the position in the fragment shader, rather we will be calculating the direction from the position in the main.cpp file. So we're going to say vec3 direction. And then we're going to have to set this in main.cpp, so let's just go ahead and do that up here. So let's replace the light.position, and let's say shader.set3 float with light.direction, and we'll set it as, let's just do, let's try the, let's do the noon, and then we'll do the sun setting. So glmvec3, 0.0fx, -1.0f in y, and 0.0f in z. Okay, now back in object.fs, now that we have a direction, we're going to have to calculate the light values a little differently. So, let me just look at this real quick. Okay, so the only thing we need to change right now is the light direction. So rather than using the light dot position to calculate it, because it's going to be applied to all of the fragments equally, what we are going to say is the light direction is equal to the normalized of the negative light dot direction. I hope that's the same name. And, well, we actually don't, so there's a discrepancy. If you want to negate the light direction, that means that you have to point it in the other way, but we're just, since we have it at -1, we're just going to keep it as positive for now. Alright, so let's go ahead and run this and see how it works. And you see that there's no more specular shit from this lamp because we negated that, but this is... I feel like I chose a really shitty thing for this. Hold on. Let me, you know, let me turn the ambience down just a little bit. So in main, let's make the lamp dot... Oh, that's why ambient is 1.0 and everything else is 1.0. Let's make the lamp dot ambient 0.1f. Let's make the diffuse 0.8, and then we'll leave the specular as 1. Alright, so let's run this. Now we should see something that's different. Oh, yeah. Oh, okay, so I guess I do need to negate it. But you see, that looks right, though. So let's go ahead and negate it. So make that just normalize negative light direction. Alright, nice. So yeah, that's how it should look like, and you see we are getting specular stuff from it. And this is like, you know what it is? It's sun overhead in Hawaii. Yeah, this thing. When the sun is directly overhead, like you can barely tell that there's stuff there. So that it's kind of, it does look like a bad video game rendering. I take that as an insult because our video game is definitely not bad, but I don't know about that one. Let's try now the sun setting. So we're gonna change the light direction to it'll be positive x, so 1.0f and 0.0 in the y direction. And you see now that everything is coming from the west, which is negative x, so that's how that should look. And it even works over there. Alright, let's just choose a relatively neutral value. I believe they do it as 135 of it. So just make it 1, and then 0.3, and then 0.5. Now let's just see how that looks. That's not right. That is actually not right. Let me look at why that is. I think I know why, but... Oh, I put in the wrong values here. Make this negative 0.2f, negative 1.0f, and negative 0.3f. Okay, now that should look a little more neutral. Okay, yeah. So yeah, that looks, it's like the light source is coming from over there. Yeah. So like it's being applied to the top and a little to the sides, or rather, it's yeah. So it's like the light source is coming from over there. And remember, specular does work. So if you so you can kind of see like that. Yeah. Okay. Nice. Okay, so that is directional light, and I would recommend, or I'm not going to recommend, I'm going to tell you, save this code for the calculation in a separate file. So I'm just going to go ahead and create a new file, and I'm just going to leave it as a text file, and I'm going to say directional. And I'm going to copy the light structure, and I'm also going to copy all of this code here. Because when we do combine it, we do want to save all this code. Ooh. And I guess we can just save it as light source, and we'll just save it as a .txt, and we'll put it in assets for now, just so it can be in the same spot. Oh, we also should include flag.specular, but that's another thought. All right, next type of light is called a point light. Oh, let me just... Yeah, it's called a point light. So a point light differs from a directional light in the way that it's a single point, and the light goes in all directions. So it's like a light bulb, a disco ball, a nuclear bomb. Wait, no, that's not. I can't say that. That's really bad. I'm sorry. I cannot say that. But the one thing that we will be changing between the directional and the point light is that the strength of the light fades over time. Because with the directional, the distance of the Earth, or the radius of the Earth, is relatively small, really small compared to the radius of the Sun, or the distance between the Sun and the Earth. So the distance that, or the decrease in strength that one would actually experience is not that noticeable on Earth, but it will be with a point light. You know, if you put a lamp, like if you put a lamp in some place and fuck off a mile later or west, you can't really see it. But if you go up to it, you can eventually see it, and vice versa. So we're going to create a point light, and we actually can integrate this point light into our lamp, because a lamp is kind of like a point light. We're going to be using a formula to calculate something called attenuation, which is essentially the strength of the light, and it's an inverse quadratic model, meaning that there's a constant term, it's 1 over a couple of terms, and some mathematicians figured this out, that it looks like that the strength starts at 1 and decreases to 0, and if you want to get all calculus, if you take the limit as d approaches infinity, you will get a 0. So the values for these constants, like I said, there's a constant term, a linear term, and a quadratic term. This is looking a little bit like a Taylor series or something. The values for these constants are there's a table of them on Ogre 3D. Ogre, you know, Shrek made those. We're gonna, keep it a solid around 65. So we can go ahead and input these values once we add the place to put them. So go back in object.fs and re-add the position, because position will matter now. And I need to hold on. I need to let me just get the light direction. All right, here we go. So light direction is going to be normalize light dot position minus frag pose, because we're just going to be bringing that formula back. And then in light, we want to add a space to have those constants. So I'm just going to name them K0, K1, and K2, and that is for the degree of the distance that is with that constant. So K0 will have a degree 0 because it's K times d to the 0 essentially. K1 is K1 times d to the 1. It's kind of like a powers. I can't find it somewhere. Right. So just anyway, just the subscripted number is associated with the degree. If you don't know what that is, don't worry. But it just creates this effect here. So we're going to say float K0, float K1, and float K2. And then we're going to say, let me just. And then in main, we're going to go ahead and calculate this formula. So in order to do that, we first have to calculate the distance between the two. So that's going to be a simple float distance is equal to the length of the vector, so the magnitude of the vector. There's a function in OpenGL to do that, or in GLSL to do that. It's called length. And we just say light.pose minus frag.pose. And that gives us the magnitude. You could go the other way around, but it doesn't matter because it's magnitude, not direction. And then we're going to calculate attenuation. So float attenuation is equal to 1.0 divided by, and then in parentheses, because everything is under the 1, we're going to say light.k0 plus light.k1 times distance plus light.k2 times distance squared. So we're just going to say distance times distance. Distance times distance. Just like that. And then as a result, or after this, we want to multiply each of the specular, diffuse, and ambient by that attenuation value. So ambient times equals attenuation. Make sure you're doing this before you declare frag color because we want the effect to be visible. And then diffuse times equals attenuation, and then specular times equals attenuation. Okay. So let's go ahead and run this and see how. I hope. Oh, I need to set the constants now. So in main.cpp, let's go ahead and just say shader.setFloat light.k0, and we're going to use the values that gives in this one right here. So we'll do it the distance of 65. That's a good middle ground right there. We can add further processing and add a table of these, and we can get that from this table over here. I'll actually bookmark this just there, just so I can have it for later. But we can actually add this table in at some point, but we'll just leave it at 65 for now. So 1.07 and 0.017. So K0 is equal to 1.0. Shader.setFloat light.k1 is equal to 0.07 float. Make sure you put the F in there. Not to pay respects, but to declare it as a float. And then shader.setFloat light.k2. And I'm going to say 0.032F. And we should be Oh, I never got rid of this here. I'm sorry, that was... Get rid of this GL draw arrays. I never got rid of that. That should have been gone a while ago because we put that in the render. That's a mistake. Oh. Okay. Position is not a member. Okay. And I say, oh, it's light.position, not pose, or whatever you named it in your structure. I have mine as position. All right, let's run this. Okay. It's going inversely. This is not right. Did I screw something up? Yeah, that's not right. Well, I mean, everything but this first cube is right. Because look, the light on that one, on that further cube is almost non-existent. It's only ambient, but that's looking good right there. But it's only this one. What the? What did I do wrong? Let me check this out. Attenuation is alright. Light.k1 times dist. It's only that one cube though, so that just doesn't make any sense. Everything else looks right. Hold on, I'm gonna do. Don't do anything. I'm gonna try and put that back in, and I hope this doesn't work. Okay, just good. Just making sure that didn't help it. Okay. Oh, it's because I'm not setting the light dot position. Oh, you know why? Okay, so light dot position is default set to 0, so that's why. So we need to make sure that you set the vector 3. Just uncomment that one, and then run it, and now it should. Oh, okay, son of a bitch. What? I don't know what that was. Okay. So, why is it not working? What the hell? I'm quite confused. Hold the phone. Hold the phone. Am I screwing anything up? I don't think so. Light dot. Yeah, that's. It's only that one cube. But I get the only reason for that would be that it's. Oh no, it is working. I'm just stupid. Okay. Yeah. Once again, this is not too realistic because there would be some light here, but because this is considered a point light, it considers it only at the center of the light. So the center of the light is not visible to this side right here. So it's working now. I don't know why I thought it wasn't. Yeah, but anyway, you see that specular still works. Oh my god, it's golden. It's illuminated. Holy shit. Whew, whew, whew. That is that. I'm not gonna lie. That actually looks kind of fun. I'm not gonna lie. I'm having so much fucking fun doing this shit. This is a lot of fun. Okay, yeah, but you see that the light, light stuff strength decreases as you go further. So yeah, that's how that works. All right, last type of light. Let's go ahead and save all of this stuff in our light source, just so we keep it for later. So this is the directional. Let's do that. So this was point lights, and we're going to paste the structure in along with the main code. Alright, there, and then the last one is going to be called a spotlight. Okay, spotlights. Alright. So yeah, spotlight, it's going to be mostly the same, except it's going to have the attenuation shit and all that, but it's going to have, so a spotlight is like a flashlight. It's like a point light, but it doesn't shoot light in all directions. Rather, it shoots light in only a range of directions. So think of like a police helicopter spotlight, you know, like GTA police helicopter spotlight. Yeah, like that. So it looks like there's a a radius of whatever, and it has a very strong attenuation, so those constant values will be close to 0. That would, because no matter, because you would want the denominator would be close to 1, because that light is going to be strong over long distances. So yeah, that's how that is. So you have in this. Don't stop making fun of me. Stop making fun of me. This is just like. This is almost like just mocking me for just my inabilities. Stop. But this is kind of cool. I'm not gonna lie. Yeah. So there's a degree theta, and that's called a cutoff. So yeah, we're gonna set that in the structure. We'll set that in the light dot cutoff here, and then we're gonna have to do some extra calculations here. Okay. Calculation. Okay, so let's head back into object.fs and let's go into light, the structure. We're going to keep the position and we're going to add float cut off. And then we want to set the cutoff. Now, we're going to do something cool here. We're going to try and simulate a flashlight that comes from the camera. So this is like a horror game or something. So the position is going to be the camera's position, and the cool thing is that the spotlight is sort of like a combination of the directional and the point light, because it's going to have a position and a direction, so vec3 direction. So let's go ahead and in main.cpp, let's go and say shader.set3float lamp.position, and we're not going to say, or light.position, we're going to, we can actually just get rid of the lamp for now, because we don't need it, or just don't render it. Keep the object values though, because we do need those values. So just don't render the lamp at all for now. Oh. And then don't clean it up either. Okay, so where was I? Okay, here. So we're going to say the light dot position is not the lamp position, but we're going to say camera, default camera dot position. And then we're going to say the light dot direction is not the sun direction, rather it's going to be camera, default camera, and we're going to say dot camera front, because that's where we are looking, so it's like we had a flashlight with us. Alright. And then we have to set the cutoff as well. So let's just say shader.set float light.cutoff, and we'll just say GLM radian, or we're going to do something kind of weird here. We're going to measure a cutoff not in degrees or radians, but we're going to measure in cosines. So yeah, this is what the graph of y is equal to cosine x, and essentially cosines is just degrees but converted into cosines. If you look at your unit circle, don't worry about this, but essentially cosine has an inverse relationship with degrees when the degree is between 0 and 90. And if you look at your, let's just say, unit circle, the cosine is the x component of a degree. So if we have a ray, let's take just the 0 degrees ray, and that's just goes to 1, 0. The x component is 1 and the y component is 0. But as you increase the angle up to 90 degrees or pi over 2 radians, the x component decreases to 0. So essentially they have an inverse relationship. And that's shown in this graph as well. So what we are going to say is we're going to say GLM cosine of GLM radians, and we'll say 12.5 radians. So that's the cutoff. Now, we're going to calculate a couple of things here. Let me just get what I need. Okay. Alright, so in object, in the main, we want to see if it's in that kind of bound. So if it's within the theta degree that the spotlight applies to. So we're going to say in the top, we're going to say float theta is equal to the dot product of the light direction. Let's calculate light direction outside or at the top, just so, because that way we'll be seeing which direction the light goes into. So we're going to be calculating the dot product between the direction of the light and the light direction from the light position to the fragment, and then we're going to say normalize negative light dot direction. So the dot product between, let me try and draw this out. This I think I can draw out. Paint. Yeah. Okay. So let's say that we had our light up here, and it's our flashlight, and our object was. Let me make it let me just make it a cube, or the top of our cube. So let's say that our lamp did something like that. And the degree theta to here, and remember this is normal, so we're going to say the theta there. So that theta is less than the cutoff. Now if we had our second cube over here, we're going to say that this theta is, or this angle is greater than that, so we won't render any light there. That's going to be in the dark. But the way we're calculating that is we're going to take the dot product between the light direction, so light direction, and the direction of the light front to the fragment. So let's look at this one first. So that goes to there. And the dot product is the parallel component between the two. And you see that it is there. And that's a pretty big parallel component. And in a different one, so this is a, let's take a look at the second thing. This is the direction of the light, or the intended direction, and this is the distance from the light to the fragment. Let me just erase, let me make it a little smaller. And remember, this is normalized, so it goes from 0 to 1. You see that there's a smaller parallel component. So essentially, when the parallel component becomes some small value in cosines, we're just not going to render anything. So what we're going to say is, if theta is greater than light dot outer cutoff, or sorry, light dot cutoff, we're going to render light normally. So we're just going to take all this code and put it in that if statement there. Just like that, and then tab that to space it properly. So essentially, if it's within, so if in cutoff, render light, and we use the, remember we're using the greater sign because using cosines and not degrees, because the dot product returns a cosine essentially because it's normalized. Okay, and then otherwise we just want to render ambient light so it's not completely dark. So render just ambient. So we're going to say frag color is equal to the 4D vector of light dot ambient times the texture, and it's the same calculation up here, this one up here. So I can actually just copy and paste that. And then 1.0. Okay. Did we finish this? Oh no, we didn't. Oh, okay. Okay, let's go ahead and run this and see how it works. Aha, so it looks like a flashlight, right? And you see that there is some attenuation affection. And look at that. The shiny badge of the Communist Party. Look at that. Nice. That actually looks pretty cool. I'm not gonna lie. And a problem that you're already probably noticing is, oh damn, this is super freaking rough, the edges. And you know, even let me just X out of this real quick. You know, the edges there are not so rough, so what we're going to do is we are going to calculate or use an outer cutoff that is like the outer cut, like the very outer bound of any light coming from the flashlight. So we're going to go up into light and we're going to say float outer cutoff. And we have to set that, so let's just go ahead and say shader.setFloat light.outer cutoff. And we're going to calculate the cosine of the radians of, let's say, 17.5 float. And then in fragment shader, we're going to say if theta is greater than light.outer cutoff. And next, we're going to have to use a formula to calculate the intensity. Because the intensity should decrease from the center of the beam of the light, as well as, so it's like it's almost like a 4D, or no, it decreases, the shader strength, or the lighting strength will decrease from the center. So we're going to use a formula that calculates intensity that involves some stuff here, and it should give us a good a good simulation. So we're going to say calculate intensity, and we're going to say float intensity, and we're going to want to put this in between zero. Let's just do the formula first. So the formula is going to be theta. So where theta is the remember that the angle between the normal and the or the spot direction and the fragment position. So we're going to say theta minus light dot outer cutoff, and we're going to take all of that and we're going to divide it by light dot cutoff minus light dot outer cutoff. And we want to put this in between 0 and 1. So GLSL has a function called clamp, and we essentially can clamp that result between 0.0 and 1.0. And then we want to multiply the diffuse and specular by that value, because the ambient should not be affected. The ambient is pretty much constant. So diffuse times equals intensity, and specular times equals intensity. So let's go ahead and render this and see how it works. So yeah, we're getting a black band, but you know what, that actually doesn't look too bad. That black band is kind of already, I'm not gonna lie. I mean, but that does look kind of normal though. Like, you see that the light is relatively constant from the center to the cutoff, and then it becomes it starts weakening out from there. So I don't know why it is. Is there? Let me check to see if this dude sees this item. No. That is kind of weird. I don't know. I guess we just have to leave it for now. If we let me try doing something here. Let me try changing this to 0.5 and see how that affects it. Alright, so that makes it more bright, but it does get rid of the black. Alright, whatever, I'll just leave it at 0. Maybe 0.1 might be fine. That actually looks a little, although I am seeing a little. Yeah, that just Because it's always going to be there. That's the problem. Oh, you know why? Make this lower bound the ambient, because then it won't be like a transition between black and ambient. Or, yeah, black and ambient. So just make this lower bound light.ambient. Let's see if that works any better. Oh, son of a bitch. Oh, ambient is not a... Ambient is a vector. Okay, let me just say light.ambient.x. Let me just take one component because it's usually the same in all three. That looks a little better, kind of. That actually does look better, yeah, especially at distance. Although there is a lighter band, like as you get closer. I don't know, there isn't really a good solution to this. Oh! Oh, what the fuck is that? What the fuck is that? That is weird as shit. Okay, I'm just gonna leave it at 0. Okay, yeah, so that's spotlights. Alright, so once again, let's put this into a file. So take struct light, copy, and then take the main code and do the exact same thing. Okay, now let's get into combining them. Let me actually just go refill my water real quickly. Yeah, I'm gonna go refill my water. I'll be right back. History is history. All right. Anyway, I hope you guys are all doing well in these trying times. Yeah. School is getting... Like, my ability to pay attention is dropped a little bit. I'm just it's just not been too, I don't know. Okay, yeah, so that is, alright, so we're done with the first part. But regardless, hope you guys are able to get through this, and you know, hopefully it's all over soon. Okay, let's go ahead and we're going to look now into how to combine these lights. I'm just going to open up my files on my other computers, or on my other screen, just so I can have all this stuff here. Okay. Alright, so let's start in object.fs. So to combine our lights, we're going to have to essentially add the results of many different lights. Now we're going to, you can already smell the arrays coming out of that. When I say many, arrays. Fuck. That's just, yeah, so we're going to be using an array to store different types of lights. And then we'll be setting those lights from within. This is actually going to be interesting to see how we can set those lights from within the shader. And it's actually going to be pretty simple. It's not going to be too hard. Okay, so let's start in object.fs. So delete everything that we have right now. Well, not everything. Don't. Get rid of the light structure, the uniform light, and then get rid of all the code in main. Alright, so like I said, we're going to have a bunch of different lights and we're going to classify them differently. So, you know, this is why I've been telling you guys, you copy and paste the code from each different light. So essentially what we're going to have to do is we're going to have a different structure for each light. So struct dirlight will have a couple of properties, and then we'll have a uniform dirlight. We're going to have a spotlight, struct spotlight, point light first, and we'll have the properties in there. Make sure you put semicolons after your structures, and then we're going to have an array of point lights. So uniform point light, point lights, and it's just going to be an array. We'll worry about the size in a second. And then next we're going to have our spotlight. So struct spotlight, semicolon, and then uniform spotlights, and then our square brackets. Okay, so that is going to be our structure. We'll fill in that in a second. So like I said, we're going to have to essentially calculate a bunch of different results and then add them together. Now we could put all this in main, but that's going to get pretty cluttersome, so we're going to put this in functions. Now you can do functions in GLSL just like you can in C++, and standard is you put your callbacks above main and then you define them below main, because like C++, GLSL reads code from top to bottom. So let's do this. So we're going to have a different function to calculate each different type of light, and it'll return a result. So each of them are going to return a 3D vector, so vec3 calc dirlight, and we'll pass in a dirlight. Or actually, let's not pass in anything right now because we can just access that uniform variable. Vec3 calc point light, and we'll pass in an index. We'll pass in an index of the array, and then the same thing for the spotlight. So vec3 calc spotlight int idx. Alright, so now in main, let's go ahead and calculate the individual results. So we'll start with directional. So let's create a placeholder variable that just is a vec3 result, and this will just store each of the values, and then we'll learn how to integrate that at the end. You turn that back. I'm sorry, I am just mixing the volumes up. I just need to find a good one because if the music is too loud, I can't hear myself talk, so I don't know. Okay, so let's start. Result is equal to calc dirlight, and we're just going to pass in nothing for now. And then for point lights, we're going to have a for loop that will iterate over the array. So let's do for int I is equal to 0. I is less than what? Now GLSL does have a function that is like an array dot length, but you cannot do that unless you explicitly size point lights. So what we're going to have to do is explicitly size it, but then just specify a number at the end, or like we're going to create a maximum bound and we'll explicitly size it to that, and then we'll pass in a number through the code, through the shader, that will specify how many lights are actually active. So we're going to do this for both point and spotlight. So we're going to say hashtag define. Let me just tweet about that real quick. Hashtag define. And nice. So hashtag define max point lights, and we'll say just 20 maximum, and then we'll initialize the array to have an initial size of max point lights, and then after that we will pass in an integer that gives us a number of them. So uniform int number of point lights. Now you might just be wondering, why do you need the sizes if you're specifying a bound up here? For some reason in GLSL you cannot call, point lights at I unless you have explicitly sized it. It doesn't like that. And I get that, and that does make sense, because if you haven't initialized the memory explicitly, it doesn't know to do it automatically. This isn't Python. You know what? I have a meme for this fucking occasion. Where's it? Where the stupid thing? Hold on. I need to find this. Pythons. There we go. This is it. Okay. Hold on. Oh, this is off of DeviantArt. Oh no, DevRant. I thought I misread that as. Yeah. When I first saw this, I actually laughed my fucking ass off. It's a shit meme, but it's honestly kind of funny because it makes sense. With assembly, you gotta stab everything. With C, you can shoot something, but you gotta hit it with a hammer. With C++, the bump stock, or the stock is stabbing you in the shoulder, 1, and 2, it's not even giving you any support because it's above the trigger, or above the barrel. And then you just also have 2 guns there, and then Python just does everything for you. This is not Python. You can go fuck yourself. This is not Python. We are not doing everything automatically. Yeah, that was my little rant right there. Yeah. So we're just gonna say from I is equal to 0 to I is equal to number of point lights, which is what we passed in, and then I++. And then for now we're gonna say result plus equals calc point light, and we're going to pass in the index of I. And then we want to do the same thing for spotlight, so we're going to say define max spotlights, and we'll just do this as 5, and then there is 5, and then uniform int number of spotlights. Okay, and then we'll do the same thing, so spotlights, and then for int I is equal to 0, I is less than number of spotlights, I++, results plus equals calc spotlight at I. Okay, and then finally, once we have a result, we can just put it in the frag color. So frag color is equal to vec4 results and 1.0. Alright, so now let's actually define these methods. Or first, let's put the properties in here. So go back into your lightsource.txt and copy all the properties from the structures and put them into your fraction. So that, and this is why it's valuable, because I was doing this and I was having a tough time getting all this stuff. Thankfully, I pushed to GitHub each time I did a different light type. So thank God I did that. So otherwise I would be shooting myself over rereading stuff. And then spotlight has those problems. Okay. Now let's go ahead and define all of these functions. The one thing I do like about not having IntelliSense for GLSL is that it doesn't scream at you whenever you have, the minuscule syntax errors. Like when I deleted the semicolon, I'm really stupid. That's really stupid, because then I miss a semicolon and I have to debug it. That was don't listen to me. Do not listen to me at all. Okay, calculate their light. Let's take the body of the function up in our store here and go ahead and copy it, paste it. and then instead of setting our or drag color at the end, what we're going to say is we're just going to return a vec3 of ambient plus diffuse plus specular. And then we're going to do the exact same for the point light, so copy and paste all that. And then do the return as well, so return vec3 ambient plus diffuse plus specular. And then finally, for the spotlight, make sure to get the if statements in there if that's necessary. And then copy and paste that. And then you have to change the spotlight in two places because we set the frag color in two different instances. So just make sure to do that. So for when we are inside the circle, you return the normal vector, or the vector 3 of ambient plus diffuse plus specular, and otherwise return a 3D vector of light dot ambient times the texture. So it should look something like that. Okay. Yeah, so that's how that works. Now so there's a lot of stuff that we have that's pretty repetitive in here. So there's going to be, what we're going to do is we're going to calculate a couple of things in main and then pass it into each function. So the first thing is the normal vector. So, or the normal vector. So vec3 normal. There's also the view direction, so vec3 view direction. And then the texture as well, so vec3 texture, the texture color. And we're going to pass in all three of these to each function. So vec3 norm, vec3 view dir, and vec3 text, and do that for each of the functions. Okay, I did screw up in one thing. I didn't screw up, I forgot to do this. In each thing we need to update where we call light, because light doesn't exist anymore. It's now each of the individual lights. So in calc dir light, what we're going to say is we're going to replace light with the dir light. So it just shows 4 instances, so dir light. So just copy and paste that several times. For point light, instead of light, it's point lights at IDX, so point lights at IDX, and just copy and paste that for each of the instances of light. So there should be 1, 2, 3, 4, 5, 6, 7. I did not count. No, I counted. 1, 2, 3. There should be 8. I didn't count them. It's a little late. It's almost 12. Give me a break. Forget it. Just give me a fucking break, will you? And then for spotlight, do the exact same thing. So spotlights at IDX, and then we'll replace all the instances there. And there should be a lot more in this one, or a couple more. But when you're done, if you do Control F and look for light, it should only show up or look up light and do case and take into consideration the case of the characters, and just type in lowercase light. You should not get anything otherwise apart from comments. Oh, I forgot that last one down there. Alright, so once you were done with that, we can go back and then add these parameters to each of the functions. Okay, and then spotlight, grab a sip of water. Okay, and now that we have done that, we can go ahead and replace some of the calculations that we don't need to do. So we take in a norm, so what we can replace is now Oh, we actually need to calculate these first. So properties. All right, so norm is equal to normalize normal. The view direction is equal to normalize view position minus frag position. And the reason why we're doing this is because for each three of these properties, they are going to be constant no matter what the light you're using is. So the normal vector will always be the same. The view direction will always be the same because that doesn't matter based on the light, and the texture coordinate is also always the same. So text is equal to a 3D vector of the texture of material.diffuse and text chord. Did I? Oh, let's pass in a text diffuse, text diff, and vec3 text spec, just so we don't screw it up. Yeah. So do the same thing for specular, and then add that. I'm sorry, I forgot to do that. Add that parameter to each of them. So text diff and vec3 text spec. So all I did there was just added another texture variable for the specular, because we have a diffuse and a specular. Alright, so now let's go ahead and start replacing things. Alright, in dirlight, ambient becomes dirlight.ambient times text diff. Next, you can get rid of the normal calculation because we passed that in. So just get rid of that line. And then we also get rid of the calculation for view direction in each of them. Here, yeah. So get rid of the calculations for normal and view direction in all of them, in direction for now. And then replace the vec3 in diffuse with just diff times text diff. And then the same thing for the spec, except use text spec. Okay, so that should be it for calculate dir. For point, get rid of the normal and view dir calculations because we pass those in. And then replace the diffuse texture with text diff, so that's in the ambient and the diffuse calculations. And then replace the specular texture with text spec. And then finally do the same thing for the spotlight. So get rid of normal and view dir, and we can actually calculate the ambient outside of the if statement, so we don't have to write the same thing twice. So just go ahead and take that ambient calculation and bring it outside of the if statement, and then replace that with spotlights at idx.ambient times text diff, just like that. And then in the else statement, just replace, just say return ambient, because we only want to return ambient light otherwise. And finally, in the spotlight, just replace the diffuse and specular calculations with text diff and text spec, but only when you obtain the coordinates. Okay, so that's all good. If we were to run this, OpenGL would scream in our face, or we would actually just be rendering black. Or, you know, let's run it and see what happens. Oh, yeah. Oh, big. No, this is actually my fault. 72. Did I screw something up? Oh, I forgot my fucking semicolon. Son of a bitch. You see, I was complaining about IntelliSense, but now it's... too few parameters. Son of a bitch, I keep forgetting to add that shit. Son of a fucking bitch. Okay. I'm sorry about that just rant there. I'm gonna calm down. Make sure you have your semicolons, and then also remember to pass the parameters into the calculation functions each time. So norm, view dir, text diff, and text spec. And then paste those into each of the other calls as well. That was kind of stupid. Alright, and then run it. then we should be getting a bunch of black. Oh, can I say that? Nope, I can't. Just a bunch of black cubes. Yeah, because there's no light being calculated, because everything is set to 0. So now let's go ahead and see how we can actually set this. So the same way that we have structures in our fragment shader, we're actually going to have structures in our code. So you can close out of everything but main and the fragment shader. And then in graphics, let's go ahead and create a new item for, and we're going to create a light header. So light.h and light.cpp. And then in light.h, we're going to do our macro. So if not defined light h, define light h, include glm, glm.hpp, and include shader.h, and then end if, and then in light.cpp include light.h. Okay. In light.h, go ahead and well, let's just go through this. Okay. So for direction light, we're going to say struct. So struct dir light. We're going to have direction, ambient, diffuse, and specular. So glm vec3 direction, glm vec3 ambient, glm vec3 diffuse, and glm vec3 specular. And then finally, we are going to have a function in this structure that will allow us to render it with the shader. So we'll be setting the values in this function. So void render shader. Just like that. Next, let's do the point light. So struct point light. We'll say glm vec3 position. And then we want a constant, so our attenuation constant, so float k0, float k1, and float k2. And then next we're going to have our ambient, diffuse, and specular, and we'll have the same render function as well. Alright, finally, spotlight. Struct spotlight. Position, direction, so glm vec3 position, glm vec3 direction, and then our bounds, so float cut off and float outer cut off, and then our attenuation constants, and so you can just copy the rest of that from point light. Okay, so that's what that should look like. And now let's go ahead and do our render function. So in, I'll let you guys, I'll give you a minute. We have been live for actually a good time. So you do see in this is that what you do see in this is that the spotlight is kind of a combination. Like you have the position from this point light, you have the direction from the directional light, you have your attenuation constants from the point light, and you also have the ambient, diffuse, and specular from both. And then the cutoff and outer cutoff is unique to the spotlight. Okay. Let's create our render function. So in light.cpp, let's do our direction light because that's the simplest. So void dir light render and pass in a shader. In here, we're going to set out the 4 parameters. So shader.set3float dir light, because that's the name of it, dot direction, and we're just going to pass in the direction just because that's the member of the structure. Shader.set3float dir light.ambient, pass in ambient. We are almost done with this. I don't know what we'll listen to after. Probably just bathe in our own silence. and then just do that for the other values as well. I keep missed. Oh, son of a bitch. Okay, so that's what your direction light should look like. Now let's do the point light. So void point light render shader. Now this is going to be kind of confusing because remember we have that array of point lights. So what we're going to do is we're going to create a name for it. So we're going to say standard string name is equal to point lights at, so do in our first part of our string point lights in an open square bracket, and then we're going to say plus std. Oh, I forgot. In the render, we also want to pass in an index because we want to say the index of the point lights, of the point lights and the spotlights. So make sure that you're also adding that in. So we're going to say standard toString idx, and then we're just going to add the closing bracket. Okay, and then we want to set all of our properties. This is going to be a pain in the ass. All right, shader.set3float name plus dot position and pass in position. Our constants, so shader.setFloat. I'm just going to copy the name plus position. You know what? Watch this program move. I'm going to copy from float in the method call, or the method name, to all the way to the position. So that, and look at this. Set float, and then we're going to say, wait, no, I can't do that. That's a mistake. Copy up to the dot, and then we should be good. Dot k0, and we're going to pass in k0. Shader.set paste in dot k1, and the same thing for k2. So shader.set paste in dot k2, just like that. And then the same thing for our ambient, diffuse, and specular. So shader.set3 paste in ambient. Shader.set3 paste diffuse. I'm gonna turn this off because this is like anime music. I love it. I love it C418, but you know, okay, that's pretty much it for the album. I'm sorry. We're just gonna bathe and we're gonna be silent for the rest of this. Okay, diffuse, and then shader.set3 paste dot specular. All right, and then the last one will be the spotlight. So void spotlight render shader int idx. Remember we added that parameter, and then we're going to take the name, and we can actually just copy everything from the point light, paste it in, change point lights to spotlights, and now we just need to add the direction and the two bounds. So say shader.set3float name plus dot direction, and then our two bounds. So shader.setFloat name plus dot cut off, and we're going to say cut off, and then shader.setFloat name plus dot outer cut off. Okay, so that's pretty good right there. Okay, now that we have all that done, let's go back into main.cpp and let's get rid of a couple of things. So in get rid of the lamp. Let's go ahead and include light. So include graphics / light.h. and let's just start off with our directional lights. So let's go ahead and delete everything where we set light stuff. Just get rid of it. And then you can also get rid of the render there. Clean up as well. Okay, so for direction, let's just create our structure up here. So we're going to say the models and then our lights. So direction, or dir light, and dir light. What do we need to pass in? We need to, let me just check my code over here. For dir light, we need to pass in our direction, so it's just equal to, and remember it's a structure, so we can use our curly braces to initialize it. So we're going to say glm vec3, the same as before, so negative 0.2f, negative 1.0f, and negative 0.3f. Okay, I was just checking a text, sorry. All right, so that one, and then comma, our ambient, so glm vec3, we'll say ambient is just 0.5f. glm, and then for diffuse, we're going to say 0.4f. And glm vec3 for specular will be 0.5f as well. All right, so that's good there. And let's render this and see how that works. So all we're going to say is in our main loop, before we, well, let's actually get rid of the light strength as well. So after we say view position, we're going to say dir light dot render and pass in the shader. So this is the beauty of having that structure function there, because now we can just automatically do that and have less code in the main loop. So let's run this and see how it works. Okay, so that is pretty much what we had before, except it's a little brighter just because we have our ambient values up a little. We can make it darker, but we'll leave it for now. Next, we're going to do our point lights. So remember what I said at the beginning, our lamp is kind of like a point light. So we do want to render an object for this point light. So we're going to try and integrate properties into the lamp. So go into lamp, and we're going to say we're going to add a member. We need to include light, by the way. So include light, and then we're going to say point light there. Let me just make sure I'm doing this all right. All right, let's keep all of our parameters the same, except we are now going to add constants. So we're going to say specular, and then after specular, pass in float k0, and we're going to do our default values 1.0f. What did we have before? We were using here. Son of a bitch. This, okay. So we were using the 0.07 and 0.017. So float k1 is equal to 0.017 or 0.07f, and then float k2 is equal to 0.017f. And then instead of initializing ambient, diffuse, and specular, we're going to say initialize point light, and then in parentheses pass in the curly braces. So we're going to pass in position, k0, k1, or wait, how do I have it lined up? Okay, so our constants come first. So k0, k1, k2, and then ambient, diffuse, and specular. Just like that. So now we have our properties integrated into the light, so we can call them as such. Let me just make sure everything else is good there. Okay, that's right. So now we want to render out our different lamps. So let's create. We're going to create several different ones, and the array is also going to be on my GitHub once this video, or once I push it to GitHub. And you know, just I'm sorry for you people, for you millions watching now, but you won't be able to get it until later. It's over here. Oh, it's not over here. It's in the next. All right, so we just have their point light positions. It's going to be another array, and we're going to say we're going to have an array of lamps. So lamp, or lamp 10 or 4, sorry, and we're going to say 4 unsigned int I is equal to 0, I is less than 4, I plus plus. And then we're going to initialize each lamp. So lamps, make sure that's plural so it makes sense. Lamps at I is equal to lamp, and we're going to pass in a bunch of things. So our color first, so glm vec3 1.0f. We're going to pass in our ambient values, so glm vec3 0.05f and glm vec3 0.8f, and then our specular, so glm vec3 1.0f, and I'm actually just going to put this on a new line so it looks a little more organized. And then our constants, so we're just going to say 1.0f, 0.07f, and 0.032f. There is room for optimization and placement of the parameters, so we don't have to initialize all this shit, but we'll just leave it for now. And then our the cube properties, so it's the position and the size. So for position, we're going to say point light positions at I, and then the size will be glm vec3, and we'll just do it 1/4 the size, so 0.25f, just like that, and that should be good. Yep. And then lamps at I dot init. All right. Now in our main, we're going to want to render each point light in the shader. So we're going to say for unsigned int I is equal to 0, I is less than 4, I plus plus. Lamps at I dot light, because did I not dot point light, sorry, because we're accessing the structure, and then we're going to dot render and pass in shader and the index, which is I. And then after that, remember there was one last thing that we did in our fragment shader, is we set the number of point lights. So we're going to say shader dot set int number of point lights, and we're going to pass in 4 because we have 4 of them. Okay. Yeah. So let's see how this looks. So now we have to render all the objects as well. So you can copy the for loop and just say lamps at I dot render, and don't pass in the shader, pass in the lighting shader, lamp shader, because this is just the lamp, so we don't want it to be affected by the light. And then also add the cleanup at the end too. So lamps at I dot cleanup. All right, let's run this, see how it works. This shit is not being rendered. Number of point lights is 4. We render them. Oh, I don't activate the light shader. That's right. That's what we forgot to do. So we have to say light shader dot activate, light shader dot set mat for view, or not light shader, lamp shader. View and view. Oops. And then, oh god damn it. And then lamp shader dot set mat for projection, projection. And now they should be all rendered. And there we go. Okay, so you see that looks good. We have 1, 2, 3, 4 as we wanted. I'll decrease the direction light just because, just so we can see the full effect of it, of the lamps. So this is going to be super dark. Yes, you see that the lamps are completely, that's one. We see the other one has the effect over here. Yeah, okay, so that's lamps. I'll keep that as that. And now let's do our spotlight. So once again, we'll just render it as a, or treat it as a stupid, as a flashlight. So all we're gonna say is spotlight S is equal to, and we're gonna say that for the position, camera default camera dot camera position for initial, camera default camera dot camera front, and then we're gonna do our bounds. So GLM cosine, GLM radians of 12.5 f, GLM cosine of GLM radians, let's say 20.0 f. Switch it up a little, and then our constants, so 1.0 f, 0.07 f, and 0.032 f, and then our ambient, diffuse, and specular values. And we'll say for this, GLM vec3, and we'll have no ambience because spotlights usually don't give ambience. We'll have, and then 1.0 for the rest because they're usually pretty bright. Just like that. And then we have to render this. So we're going to say, in the main loop, remember we want to update the position each time with the camera. So we're going to say s.position is equal to camera default camera dot camera position, and then s.direction is equal to camera default camera dot camera front. Yep. And then we want to say s.render shader 0 because we're only using one here. And then after that we have to set the number of spotlights. So shader.set int number of spotlights 0. All right, let's run this and see how it works. It's not working. Why is this giving me a, why is this, why do you persist? Did I forget to do something? Spotlight, no errors. There was no compiling errors or anything. Oh, I said 0 spotlights and he did make it 1. Stupid me. Stupid. All right. Let's look at this now, and whammo. Hell yeah, bro. Fuck yeah. That looks fucking sick. Yeah, so this looks a little bit like a horror game, doesn't it? You know, if there were no other lights, you know, ooh. Fucking hell, oh my god. Oh, it's so nice. Yeah, so that's a lot of stuff actually, and for the last thing I wanted to play around with was let's make it like a flashlight. So let's add a toggle button. So let's do a boolean. So bool light or flashlight on, and it's set to false initially. And then in process input, let's say let's use else. So if keyboard key went down, remember we're using that more advanced function, and we're going to say glfw key L, and we're going to say flashlight on is equal to the opposite, so not flashlight on. Okay. And then in our main loop, we have to say if flashlight on, we want to render it. But we do have to take care of something if it's not on, because if it's not on, it's just going to, the shader will use the previous values, because it's not like every time you render the shader values get set to 0 again. So we have to say else, we just want to say shader.setInt number of spotlights and just say 0, because we don't want any of them there. Alright, and let's go ahead and run this. Alright, so okay, and let's flip our light on, pressing L, and like that. And let's try turning the light off. That's kind of weird, that border off. Oh my god. Oh. Oh, that's that. Alright. I'm having too much fucking fun doing this. This is honestly, I love doing this shit. Holy crap. Yeah. Yeah, that's all I have for you guys today. This has been almost 2 hours. God damn, I wasted too much of my fucking time. Okay. The code for the positions will be on GitHub once I push it. But yeah, I'm done. Yeah, that's about it. I'll see you guys in the next video, and I believe I'm not sure what we're doing yet, but I believe we're going into model loading next. But we might continue with lighting. I'm not sure. Yeah, that's about it. I will see you guys then. Bye.